Okay, welcome from Slopeside. It's Sunday afternoon, and I wanted to, while I'm out here freezing, I wanted to go over blood flow direction in the heart, and it's a classic question to be able to follow a blood cell, let's say from the lung through the system of your body. So if we look at the heart straight on a diagram like this, of course you'll need to be able to label a diagram like this, but let's just worry about blood flow to begin with. Looking at the heart straight on, and this is the classic diagram, this is your right side of the body. So it's almost like you're looking at a body laying on a table. So this would be your right atria. Atria is the chamber up top. This is your right ventricle. This is your left atria and your left ventricle. Now these two areas in here, one is a tube that's heading out to your lungs, and one is a tube under the tube to the lungs, shoots under here, and it comes out to your aorta. And if we think of that double circuit, how for one pump it goes to your lungs, and then the next pump it goes to the rest of your body, it gets a little clearer. So let's start over here. Let's say you have your blood cell and you're down here. When your heart contracts, it's going to go shoot up here and up the aorta and go to all areas of the body. So if you were to start in the left ventricle, because this is the left side, ventricles are on the bottom because they're like a V down here. This is your right ventricle. So I want to test, you don't know where you're starting, but a red blood cell starting in the left ventricle would travel out the aorta, and one of these will go to the head, they'll go to the arms, they'll swing around down to the liver, abdomen. So then they're going to your body systems, whatever they are, and they return to your heart, left ventricle, out the aorta, to the body. The next time we're going to see it, it's going to spill back in through your vena cava. So this is your vena cava. It's going to spill back into the right atria, down to the right ventricle. Your heart will contract and shoot that red blood cell now up to your pulmonary artery, and it will either go, and you can pick this when you write your essay, right or left lung, goes to the lungs, and then at the lungs it will drop off CO2, and we should know pick up oxygen. So after it goes to the lungs, it's going to return into the back of the heart, into the right atria. The left atria, right here. Left atria, and then down to the left ventricle, and it starts all over again. So if we had to write it in order, we would, we had to write in order, and you need to be able to start anywhere you go. So it's right atria, right ventricle, lungs, left atria, left ventricle, body, right atrial, right ventricle, lungs, left atria, left ventricle, body. We'll do that again. Right atria, right ventricle, out to the lungs, in from the lungs to the left atria, left ventricle, then out to the body, goes to the systems, it returns, everything pulls back into the right atria, right ventricle, out to the lungs to get oxygen, drop off CO2, back from the lungs to the left atria, left ventricle, and then out to the body. So double circulation, this side only pumps to the lungs. Something to note here, this muscle is very thin. It only has to pump like 6 inches. Your lungs are right here, right? They're right next to your heart. Very thin muscle, not very strong at all. It's pumping a very short distance, 6 inches, and boom, it's all there right in the lungs. This side, however, look how thick that muscle is. And form fits function. Why? You need all of this muscle because when this contracts and shoots out the aorta, it's got to go everywhere. It's got to go all the way up to your head. It's got to go to your liver and your stomach and everywhere, all under pressure, these very thick wall pressure. So I have another picture I thought was interesting to show you. Just looking at this, if we were to envision a heart, you'll have a heart. It's kind of like a 3D structure. They cut the heart this way, about an inch out of it. Let's say you have your aorta here and your pulmonary arteries go into your lungs up here, and this would be your apex. They cut a section out of it, so they went through both the right and left ventricles. So you're looking right here, one chamber, very thin wall. This very thin wall chamber, even if you don't know which way the heart is, you can deduce that this must be being pumped to the lungs. This really thick chamber, you can see how thick that muscle is. And these are both ventricles. The atria, when you do the dissection, you'll see they're very, very thin because they just collect the blood. This guy does the pumping. So it's almost like a toilet. If you think of a toilet, and I'm winging this one, you know how the water stays in the tank. So here's your water in the tank. That's like your atria. Then you flush the toilet, all this water runs into the bowl, and down it goes. The bowl is like your ventricles. It's going to pump it away. So this is like an antechamber beforehand, and then the toilet has the mass and all the muscles. That's what your ventricles do. Now when we look back here, what side of the heart goes to the lungs? Well, the right ventricle pumps to the lungs. So no matter which way this picture is, the right side, you can tell right away, this is the right ventricle. It's not very strong. It pumps to the lungs. This is the left ventricle. And actually, this is what's called an infarction. Or you might know it as a heart attack. You can look at this tissue, and this tissue died. It died from lack of oxygen, and then it went necrotic. But we'll get into that with heart disease. So, study up hard on, whoa, it's like 20 degrees, feels like 6 here, but the powder is wonderful. Study up hard on the flow of blood. Very classic question to be able to follow a blood cell through the heart. So practice doing that. Practice writing it nice and slow. And over and out. See you Tuesday morning.